I know we have some new virtual folks, so videos might be 2 parts because of our break typically. So, oh, you guys need notes, you guys.
Yeah.
That would be nice.
Gary has us.
I was just gonna.
Okay, so the issue is, the stapler wasn't working when I went to print these. So they're 2 separate pages, but if you really want to be stapled, we can send a stapler. Yes.
Maybe. What?
So you guys at home, the answer keys up on the board for the homework. I haven't been good about posting that for you guys, so that is up there for you.
Oh.
This is today's, there's 2 pages. But you should be able to glance at it and think it looks somewhat familiar,
No.
hopefully. This is actually something we did review in geometry.
Oh, yeah.
I'll send a stapler around if you guys want to staple them. If you
Yeah.
don't care, send it on. It's Wade. Talk about graphing linear equations today. Like I said, it should be something that looks somewhat familiar. I know at one point I taught most of you guys this stuff. Alright, so the warm-up question asks you to find the y in the following equations if x equals 0. So they're telling you that x is 0, and they want you to find the y value. So if you know x is 0, can you find the y for a, b, and c there? Well, in there. Or I get one.
Garrett didn't pass it forward,
Yeah.
so.
Oh my gosh. Garrett wrecked everything.
Yeah.
Yeah.
He's having a rough day. All right, do you have any volunteers to come put these up?
I'll just.
Garrett, come on up. Pick whichever one you want.
Yes.
And then,
I better not do this one.
Can I do C?
yeah. Do you want to do A? Are you okay with doing A, Ethan? Okay. Yeah. All right, Abby's coming up to do
Yeah, Abby.
C. And you can start writing. You can use a different pen. As long as she doesn't start erasing, then it gets awkward.
Don't give me ideas. Okay. The zero's gonna disappear, but like, you know what happens. Oh.
That's okay. We get the idea. It's okay. All right. So we got y is -7 here. So the 0 cancels out that x. This one, like Garrett said, I mean, hopefully he gets it right. He puts 0 in here. That whole side becomes 0. And then finally in letter C, Abby puts it 0 in his x, and it, like she said, it disappears. You can kind of picture that first half of the equation going away altogether. So, and negative or positive 4 is correct. So what we just did here was a really important idea that we're going to use today. and we actually found the y-intercept in all these cases. So we're going to do that quite a bit. We do that a lot with graphing. Y-intercepts are a really important part of our graph. It makes it really easy to graph. So we like the y-intercept. So we're going to be graphing using intercepts, talk about linear equations, talking about some different slope-intercept form. So we're going to kind of do a bunch of review. Like I said, this is probably something you guys learned in geometry and in algebra, but you probably took almost a whole chapter for it, and we're going to kind of like blaze through it here. So linear equation, tell me something you guys know about a linear equation. What does a linear equation look like when you graph it? The name kind of gives it away, yeah. It's a straight line. So when we talk about linear equations, we're talking about straight line graphs. So the graph has a straight line. So we don't want a graph that looks like a U, like kind of like the one we graphed in our warm-up yesterday. So like a U graph would not be a linear equation.
You mean Friday?
Oh, Friday. Yeah, we weren't here together yesterday. And we're going to write down some criteria that would tell us if something's going to be a linear equation or not. So I will kind of do some examples and then non-examples, the ones that don't work. So the first one is x can't have an exponent. Sorry, I was going to make that an asterisk and then I started writing x. X cannot have an exponent. So underneath the examples and non-examples, I'm going to write like an example like that and then one without. So, or one that doesn't work. So x not having an exponent is like y equals x would be fine. Would it be an example of a nonlinear equation? Would be y equals x to the second, x to the third, x to the fourth, anything that has an exponent other than a 1. The next one is x can't be in the denominator. As soon as you put x in the bottom of the fraction, it becomes nonlinear. So just a reminder, the denominator is the bottom of the fraction. Now it's okay for x to be in the top of the fraction, but not the bottom. The minute it goes into the bottom, it's no longer a linear equation. So y equals like x over 3 is okay, but y equals 3 over x is not. That's not linear. And if any of you guys have a fancy graphing calculator, you could put those equations in and see that they're not linear. They're not going to be a straight line.
Syntax error.
All right. Next one is x and y can't be multiplied to each other. Now it's okay if they're multiplied to something on the opposite side. So like I have 2x equals 3y, that's okay, but x times y equals 3 is not. So that's linear on this side, non-linear on the other. And then finally, x cannot be in a square root. I'm going to say under the square root. So x is not under the square root, it's okay. If x is, then it's no longer linear. So these are all non-examples, which means these are all non-linear functions. ask you a ton of questions on these, like kind of just being comfortable. Oops, this is kind of what we're working with over here right now. This is tougher math, like these are harder problems that we're not gonna really get to too much, so we're working more with these types of problems. So just kind of letting you know kind of what is possible. So we'll talk about if something's linear or not based off of those criteria now. So if you go down to the bottom examples, and so if you want to look at those and try to decide using our criteria, are they linear or not linear? And then it says, if it's linear, solve for y. So if it's linear, then we want to get the y alone. Take a minute and decide if you think they're linear or not linear. If it's linear, we should be able to solve for y. So even if you just write down not or is linear or not, whatever happens to be, we'll decide if we get the y alone together. So what do you guys think? Example 1, is that linear or not linear?
Non-linear.
Non-linear, why not? And
The
say,
X and Y is on the same side.
yeah, so this is non-linear. We have that x times y, that's not okay to do that, so that's what makes it not linear. So this one we wouldn't solve for y, we just leave it the way it is. Now example 2, sometimes if you're like, oh, I'm not sure, one of the things you can do is try to get the y alone and see if it ends up looking like one of the ones we don't want. But it looks like something's being multiplied to x here, that seems okay, there's y's on each side. So let's get the y alone and see what this equation ends up looking like. So what do you guys want to do first? How do we get y alone? Let's see if we can do that. Yeah, Ethan?
Right, 2y from each side.
Yeah, you want to move the 2y? Okay. If you guys move the y instead, that's fine. Doesn't really matter. So the negative 1y plus 4. Our next step then. Yeah, so now we're going to move the 4 back over. And then the only thing different with this one, maybe that you didn't have to do, is we want to get that negative 1 to go away, so what do I have to do? Yeah, I'm going to divide everything by negative 1. So my equation ends up being, I guess let's go here, y equals negative 0.3x plus 4. So x is not in the denominator, x is not being multiplied to y, x is not underneath the square root, and the other one, x doesn't have an exponent. So this one is linear. So that one's fine. That's an equation we would know what to work with on it, and you'd be able to graph it. So when I'm asking you to get y alone, this is what I'm asking you to do. Just solve for y. Okay. Now example 3 is a little weird. Anyone see what's going on there? Is there an x at all? No, there's not even an x. So we might have to think about this in another way. All of our criteria had to do with x. So again, let's try to get the y alone. How would I get y alone in this case?
Divide by third.
Divide by third or
Multiply by 3.
multiply by 3, either way, same thing. You're doing the same thing in each way. Do you guys remember what type of line it is if I have just y equals something? What line is it? So this one's a flat line. This is the zero fund flat line. So y equals 36 would just be a flat line at 36. So is that linear? Yeah, it's a straight line. There's no x involved at all, so we don't even have to worry about any of the x criteria because it's really not even there because there isn't an x in the problem. And then finally, the last one, what's wrong with it? Hopefully you realize it right away. The x squared. So we can't have that x squared. So nonlinear. Why don't you guys flip the page, please? So what I think we're gonna do is we'll do some problems involving graphing our intercepts first, and then we'll take a break, and then we'll come back and do slope-intercept form. So I think our break today will just be like, we'll just do whiteboards or something outside. All right. So our intercept. So again, we talked about this a little bit in the warm-up question. Where's the interceptor? How do we find the x or y interceptor? What do you know about the intercept? Tell me something you guys know. In the warm-up question, we were finding an intercept. What does that mean about one of our variables? Anyone remember? Okay, I'm going to give you guys a little bit of help here. So the intercept, just in general, is where the graph is on one of the axes. So the intercept, where the graph intersects either the x or y axis. Where the graph intersects with either the x-axis or the y-axis. So where do you think the x-intercept is? When do you think that one is? It's the x-axis, so it's where the graph hits the x-axis. Sleepy.
Monday.
Yeah. Where the graph hits the x-axis. What do you guys know about points on the x-axis? We know something about all the points on the x-axis. So like if I have a point on this axis, what do I know about all those points? They all have the same thing in common. What do you guys think? So if I have an x-intercept at -4, what's the coordinate point for that?
-4, 0.
-4, 0. What's true about the point right next to it? What's also going to be the same about it?
0.
The 0. So what do we know about 0? Which variable is that?
Y.
That's the y. In the x-intercept, the y always equals 0. This is the really important thing I wanted to get out of you guys. And again, you guys are making me kind of nervous. Either you're sleeping or you don't remember anything I talked to, or both. So any of those parts are troublesome for me. So the y-intercept is just the complete opposite of that. So this is where the graph hits the y-axis. So in this case, it would be up here, 1, 2, 3, 4, 5. And what do we know about that point?
The x spot.
The x is going to be 0. Very good. So this would be 0, 5. And if I have 2 points, I can draw a line through 2 points. That's a straight line. Like I can make a line that connects those dots. And that's going to be my linear equation there. So it says graph a line with these intercepts. And if you can draw straighter than me, good. So we can draw that line right through there, and there's our graph. Now, they're not going to always be so nice to us. They're not going to tell us exactly what the intercepts are every single time. So they may just give us an equation, and we have to figure out the intercepts from that. Just a quick reminder, if you forgot, this is the x-intercept, or the x-axis, y-axis, vertical is y. So we're gonna look at the two examples down at the bottom, the 6 and 7 down there, and be able to figure out the intercepts based off of what we know. So these two ideas, that y equals 0 and x equals 0, we wanna find 2 points. So in this case, since to graph this equation using intercepts, and we wanna find out what those intercepts are. So I'm gonna use what we just wrote down up on the top, since we forgot, over the summer, we might forget over the last 5 minutes here. The x-intercept, what do I know about the x-intercept?
Y equals 0.
There we go, y equals 0. And then the y-intercept is where
X equals 0.
x equals 0. So what I can do, and those are two separate points, what I can do now is figure those out based off of the fact that I know how to substitute a value in and find that other variable. That's what we did in the warm-up. So for y equals 0, I'm putting 0 in for y. Now, if you want to admit it or not, Abby knew what she was talking about here. On her warm-up question, she had said that that part disappears. Like she's like, it's gonna go away. She pointed that out. Because anything times 0 is just 0, this really just goes away. So you can kind of just ignore that part and say, well, 2x has to equal 12. And that's a pretty easy equation to solve. So x ends up being 6. So I have a coordinate point of 6, 0. So I'm able to figure that out pretty easily because putting 0 in is just a really nice number to put in. So 6, 0, my point. So on the x-axis at 6, I put a dot. And then we're going to do the same thing for y. Again, if you're like, I know that 2 is going to cancel now because of the 0, you can probably just leave it out. Always makes me nervous to do that with my notes because I'm afraid someone will look away for a second and be like, where did the 2x go? So the 2x becomes 0. Negative 4y equals 12. So we're dividing by negative 4. So y ends up being a negative 3. And again, this is my other point. So this is 0, negative 3. And so now we have 2 points, and that's enough to draw a line. Now, it's not the most precise line in the world, because we're going to see that with some of our other points, we're going to have a lot more dots, or my other equations will have a lot more dots, but 2 dots are enough to draw a line. Now, the next one is a little bit trickier, because one of the variables, one of the intercepts is going to be a decimal. And this is why we don't always graph by intercepts, because as soon as we start talking about decimals, it becomes less and less precise because it's harder to draw that in a way that is accurate. We okay on our intercepts there? So again, same idea. The y-intercept, or the x-intercept is where y is 0. X-intercept, or y-intercept is where x equals 0. I'm not talking, like, stop listening to me currently. I'm saying the opposite of what I mean. So I wrote what I meant. But again, this time the x-intercept is going to be a decimal. And so that might make you think you're doing something wrong. This is just trying to show you that it's not always going to be nice whole number intercepts. It's probably more likely that it would be a case like this. So if I put 0 in for y, I have 3x minus 0 equals 8. So that'll go away.
Okay.
So 3x equals 8. And so this is where kind of a goofy decimal comes into play, because that's going to be a repeating decimal even. It's going to be 2.6 repeating, so about 2.7-ish. Now, on my graph paper, it's going to be like really hard to tell where 2.7 is versus 2.6 versus 2.8. It doesn't, I mean, it's not like you're going to be like, ooh, Mrs. Donahue, that wasn't a very good, I mean, I'm just coloring basically the space between the 2 and the 3. It's not very accurate, and that's okay. Like, I mean, that's why this is always the best way to graph. So about 2.7-ish And then I'm gonna put the 0 in for x. This one works a little more nicely. That becomes 0. But I can't leave this as a negative y. What happens? Divide by a negative 1. So y ends up being a negative 8. And so that's my y-intercept. So I'm going to go all the way down to negative 8, way down here. And then I can just draw a line through those two.
Steve.
Really puff positive.
Oh, yeah.
All right, so should we take a break?
Yeah.
Yeah. Okay, so online, sorry, we're taking a break. Come back to the next video.
Go outside, enjoy the
Yeah,
fresh air.
Go do some jumping jacks outside.
Get a snack.